I'm going to give you a quick demo today of Registrator, which has been around for a while, but I wanted to give a demo of it. It's a service registry bridge for Docker. So you're starting Docker containers and you want to register them automatically with a service registry for service discovery. So it works with systems like Consul and etcd, and you can write plugins for any other type of service discovery system you want to use, like Zookeeper or something like that, or Eureka. It was originally made for Consul, so it specifically takes advantage of the Consul service catalog, although you can actually have it use the Consul key value store in the same way that it would with etcd. But a lot of cool features come with the service catalog demo, so that's what we're going to use. So Consul, if you're not familiar, it's sort of like etcd with a bunch of extra features, and I won't get into it. I gave another demo of using Consul in Docker, which you can check out. But so we already have a Consul set up here running, and let's see, we can actually see it running here. And so once you have a Consul cluster system set up, you can actually just run Registrator. And Registrator is pretty easy to start. Basic things are, you run as a daemon, you have to give it the Docker socket, so you mount the Docker socket with -v. It's a good idea to give it the host name with -h Registrator, and then we give it the registry backend. And so here we specify console:// and we're giving it the public IP of this machine, which is what I bound console to. It's not usually a good idea, but for the demo, that's what I'm doing, port 8500. And we just run it. And we should see that it's running just fine. And at this point, once it's running, you can basically just start any Docker container. And that's the really cool part. You don't really have to do anything extra. So let's say we want to start Redis, and we're just going to use the Dockerfile Redis container. Dockerfile is a organization on GitHub or a group or something. I don't know. They make a bunch of pretty good Docker containers, and this is a pretty straightforward Docker container. There's really nothing special in here. It does a from, run, volume, and nothing else. It exposes 6379, so it's not doing anything special for service discovery. So I just wanted to point that out. So we can actually, if we just run this, we'll run as a daemon, Dockerfile, Redis. And actually, we're going to, normally you would do -p and specify the port that you want to make accessible, the port you want to publish. In this case, we're actually going to do P and not specify anything. And what this does, you don't normally use this with Docker, but it's actually very handy when you're doing, when you have service discovery like this, because when you do -P, it's actually going to publish all exposed ports on a random port. So you can actually see that here. There it is. So it's on this random port, and normally you'd have to do something special to find out what that port is and put it somewhere. You know, if you're using service discovery, console, whatever, you have to register it. But it turns out that's already been done for us. If we go back to this, our console cluster that lists services, we actually see Redis listed here already. So that was just kind of magical, and it was named Redis. The service name is based on the base name of the image name. And if you want to specify, I'll show you later how you can override that. But it actually makes most sense to do that in most cases. So you've seen that we can actually, because Consul runs a DNS server and we have it running on this machine here, we can actually use it and look up Redis now. Whoops. Didn't need to give it that. And so now it's giving us the IP of Redis, and of course that's not terribly useful. What we really want is the SRV record. And so that will actually give us the port that it's running on, which is really great. Okay, so that's interesting. And if I were to kill Redis, and it's now dead, and we go back here and look at our list of services, Redis is no longer listed. So it automatically registers containers that have ports that they expose and automatically deregisters them. So that's sort of the magic of Registrator. But let's show you actually, this is actually a cluster of nodes, Consul running across 3 nodes. And this is where this is kind of where the power comes from, is having this service discovery across the cluster. So you can actually see I'm just running these 3 nodes on DigitalOcean and running Consul on all of them. So what I'm going to do now is I'm going to start Redis again. Redis. And this time, so you can override various properties of the service through environment variables, and this is really important because it means that operators can set them to whatever they want, but it also means that the author of the Docker file can specify what they think they should be inside their Docker file by setting the environment in the Docker file. So for example, I'm going to run Redis this time, but I'm going to call it DB instead of Redis. So we do that, and we see that we have a DB service here. And I'm actually going to go to node 2 now. I'm actually going to run the same thing on node 2, but I'm actually going to add another feature, another environment variable, service tags. And so Registrator supports arbitrary metadata given service underscore something, including service underscore and the specific port, internal port. No port means it's going to use, you're referring to either the defaults for all of them or the one single port that's exposed. So service tags is actually going to set the console tags for this. So we'll set a tag and we'll say that this is the primary Redis DB. For some reason, I don't know why that's useful, but we'll do it. And if we go back here, we can see that we have 2 passing, and well, one of them is primary. We don't know which one, apparently through this UI. But I'll actually go to node 3, and I'll do a dig. I'm going to use bridge IP since I don't remember what it is now, and just look up DB from service.console. So this is on the 3rd. We're running Redis on node 1 and node 2, not on node 3, but we're saying what if we want to access it? We can actually do the lookup here and get the IPs of the other hosts that they're on, and of course, like I said, we can actually get the specific IP and port that they're on, so we can connect to them directly. So that's really cool. Another feature is that tags, we can actually look up the primary database, and it will give us the one primary, the one tagged primary. And then if we do this lookup every time, Consul's actually going to give, if there were more, if there were more instances, this would be more obvious. The answer section for the SRV records, they're actually served in a random order, so you can use this for random load balancing as well. So one last thing I want to show you is how, as an author, you can specify these defaults. So you can kind of build your images to work with Registrator. And I think it's important that Registrator does work with a lot of different backends, service registries. In theory, it will. But what's more important is the conventions it sets for these environment variable metadata. I think a couple of other projects have already used this. So containers that are using service underscore stuff to define metadata for services for Registrator will actually work in a couple of other projects. Okay, so let's make a Docker file here. If I have Vim, I do, so we'll say we'll make a new image based on this one, and we're just going to set service name to DB. Docker build, we'll call it Redis. Oops, yeah, that's silly of me. It's kind of annoying, isn't it? So now if I do docker run dp, so what's great is capital P, you don't have to worry about those at all. Redis, right? And of course now we have three instances of Redis as DB, and when we ran it, we didn't have to set any environment variables because it was already built into this image that we were using. So that's it. Project is called Registrator, and you can check it out and add more backends or submit issues or whatever, and then keep an eye out for the last project in this trilogy of projects, leading to a kind of project that pulls them in together as one solution. Anyway, thanks.